All right, so we're going to start talking about assemblies in NX. The first one that we're going to talk about, the first type, is going to be bottom-up assemblies. Now, in this method of assemblies, we essentially have all the parts already designed and modeled, and this is just going to be a way for us to bring all the parts together and essentially assemble them as ideally as they would be assembled in real life if we had these parts actually made. So I have all of the parts for you. There is a zip folder on Canvas that needs to be downloaded, and you'll need to extract the folder that is inside that zip folder. So inside the zip folder, there's another folder. You'll need to extract that. All the part files are in that folder. Now you'll need to extract the folder from the zip folder, or else it's going to have some issues with actually accessing the part files and saving to the location. And that's the other important thing. We need to make sure that we're saving to that folder. So save to the folder that has the part files in it. So we're going to create a new file. You can go do an assembly here. We're going to name it Vise assembly, and we're going to make sure that we save it to that folder that contains all of the part files for the Vise itself. You technically could just go to a model. In fact, if you started a model regularly and then just go to the assembly tab, it's no different from what we're doing here. We'll still have a .prt file with our assembly file, so not much different as far as the file types. So we'll say OK. Now when NX loads, you'll probably see this assemble window. You can go ahead and close out of that. We're not going to be using that. We are going to go to the assemblies tab here, and we're going to use some of these tools that we have here. We're going to go ahead and add in our first part, and for us that's going to be the Vise base. So to add in the parts or the components, we will over here to the left, we have add component. We're going to click on that. This window should pop up, and we should have a list of parts that are essentially available to load in. These should be the components that are in the folder that we have saved this to. If these are not here, you'll see this folder here that for open. If you go to that, then you can find the folder where all of our parts are located at and access them there. So either way is fine. So the first thing that we're going to add is our Vise base. We can go ahead and click on it. Now when we click on it, look, notice that mine appeared here. That might not be the case for everybody. So let's look through this add component window and do what other options we have. First thing we see is the count. So if we wanted to add multiple of these, we could increase the count and add multiple of these components. We only want one of these. Next is the location. So the location and the placement kind of go hand in hand. Notice that the placement we have as move. So essentially it's allowing us to move the component in our absolute coordinate system for this assembly file that we have. And if you notice here, so move is selected, and if we go back up to the location, it's asking us for essentially how do we want to locate this. So we've already identified that we want to move it. Do we want to move it based off of the absolute coordinate system? And let's say that we do. But how do I move this? Well, right below the move, we have specify orientation. So if I click on that, then we get the manipulator arrows that pop up, and we can actually, move this around just by clicking and dragging, or we could actually type in the coordinates. There's some other ways that we can move some parts around though. One is snap, and snap is if you clicked on the Vise base and you didn't see anything. What probably happened, doesn't always happen, but sometimes it does. What probably happened is that you had snap set, and if snap is set, sometimes you actually have to like drag the mouse over on the screen for it to actually show the part that's you want to move to. Snap is just, it's gonna, wherever I click, that's where the part is gonna be located at in space. So those are kind of the two ways that we can actually locate the part. These other coordinate systems are similar to what we just saw with the absolute. It's just that you're referencing other coordinate systems. I don't have to move it anywhere though. So I'll actually cancel this and do this again. I don't have to move it at all. I have another option here as constrain. So if I click on constrain, I actually have some assembly constraints that I can use to constrain this part without moving it anywhere. So sometimes, I might insert or add a new component, and I can just constrain it here immediately. So I don't have to necessarily move it around. Now I typically don't use this method. I typically just move the part like away, and you'll kind of see what I mean by that, and then add the component and then constrain it later. But you can constrain it here. There's nothing wrong with that. So, so once the part has been added, you can move it, you can constrain it. For our first part, typically the first part that we add is the one that we want to not move. So essentially with our assemblies, our goal here is to constrain each component similarly to how it would be constrained in real life. So if I have a shaft that's going to be rolling along some bushings, I constrain it so that the shaft can rotate, but not move out of the path of the bushing. So it's going to be located centrally between the bushings, but not allow any movement so that it doesn't like move away from the bushings, but it can still rotate. So we can constrain parts to move in certain ways and not in others. But typically with the first part that we add, we don't want it to move at all. So if we think about this vise here, I don't want the vise base to move. I want to be able to like move the movable jaw in and out, right? But the vise base, I don't want to move. So typically the first part that we add in is one that's going to be fixed. That is going to be a constraint. And I know I just said I typically don't do this, but with the first part, pretty much always is going to have a fixed constraint. Not every single time, but most of the time. So we can go to constrain. We can add in a fixed constraint, and we'll just click on our part. Doesn't matter where. You can kind of see it there. And we can say OK. And you'll notice that when I added in the vise base, we've got all the sketches, all of the planes, everything that is open in the part is shown here. Sometimes this is what we want. So this is nice so that if I want to position this part or constrain this part based off of maybe one of these planes or a sketch or something, I have access to that here. But maybe I don't want this. Maybe I just want to see the actual solid body, which, to be fair, typically is what we want. I'm going to come over here to my menu, and let's look at a couple other things that we have. So we're used to the part navigator. The part navigator is, when we're actually modeling, we get to see the history of the model. We have a couple other ones here, though. Let's look at those. So the first one is the constraint navigator, or I guess the next one up is the constraint navigator. This shows all the constraints that we have in our assembly and the components that are used to constrain. So right now we have a fixed constraint just on the vise base. So maybe if we needed to adjust this or change what was being constrained, we could do that here. But for us, we actually want the fixed constraint on the vise base. So this is fine for us. The next, so the top one is our assembly navigator. So we've got our part navigator and our assembly navigator. The assembly navigator is telling us what parts are in our assembly, and also they're giving us some information about the order, the hierarchy of our parts. So you'll notice maybe you can kind of see it here, but as we add parts, you'll see it a little bit clearer that we have this tree starting to develop. You can sort of think of this as the structure of like a computer. So the hierarchy of folders and then documents in that folder. So documents that comprise that folder, right? So here, NX calls these parents and children, okay? So the parent file would be our assembly file that we have, right? Now the parent file is made up of these children files. So you can kind of see, so if I were to click on the minus sign here, right, all I see is this top file. Now that file consists of, right now, just our Vise base. But as we add more parts to this, it'll start to add more children to our parent file. Now we could have done this a slightly different way. We could have started with the Vise base opened. So this could have been our main file. And then we could have come up here to new parent assembly. Now when we do that, what this does is it actually creates an assembly file as the parent and adds the Vise base to it. So we would have this same structure here, but we could have gotten here a different way. Another thing about the assembly navigator is notice that our parent file, so the Vise assembly file, is bolded. This means that it's our work part. It's our current work part. So if I were to add another component, I'm adding it to this file, part here. Anything that I do, if I were to add a sketch, right, I'm adding it to this file here. Let's say that I wanted to do some work on the Vise base file, right? I can actually do that still in the assembly. So if I right click on this and say make work part, notice here now the Vise base is bolded. And once we add more components to this, you'll see that if we had 2 or 3 other components here, those other components would be grayed out and we would only be able to really see the Vise base. Now if I go to the part navigator, right, you'll see all of the tools that were used, the history of making this Vise base, right? So we can edit components in the assembly file itself. We'll actually utilize that when we start talking about the top-down method of assemblies. So for this assignment, we are going to want to keep the Vise assembly our work part. So you can either right-click and say make work part, or double-click on it, but you do want to make sure that the Vise assembly is highlighted. Now this is my work part. If I were to go to my part navigator, notice that I'm looking at the history of the Vise assembly file, not the Vise base file. I'll go back to my assembly navigator. I do want to, I mentioned earlier about how this part was loaded. It was loaded with all of the geometry and sketches and everything else, which can look kind of messy if we don't need it. This is the reference set. So when we add in the next component, we'll look at how to change that. But we can change it after it's been added. That's fine. So if I right-click on the Vise base file in the assembly navigator, or right-click, you'll see here, replace reference set. Right now we have the entire part added in as a reference set. So it's referencing the entire part, right? If I select just model, notice that now it's just added in the solid body of our part. And this for us is what we want. We just want the model itself. Let's add in our next part. So we have the base in, okay? let's add in the slide bar. So this bar right here, this is the rod that the movable jaw is going to slide across as the lead screw is either turned in or out. So let's add that in next. So make sure that the Vise assembly is your work part. If you had Vise base as your work part and you went to add component, that would actually add the component to the Vise base part file. So it wouldn't add it to this assembly. This would actually be a subassembly, which is just not what we're doing right now. So make sure that Vise assembly is your work part, and we will go back to add component. And we want the slide bar. So I'll click on the slide bar, and here it is right here. Now, this is what I like to do with most of my models. So I'm just going to move this out of the way a little bit. Just, obviously it's not going to go right here, but I'm just going to move it a little bit out of the way, and I'm just going to say, okay. Now, I did not add any constraints, right? So just like, or here with this part, we added a fixed constraint. So if I right click on this and try to move it, it's going to say, hey, you're trying to move something that's been fixed. Are you sure you want to do this? I'll say no. But if I try to move the bar here, I can move this around. I don't have any fixed constraint or anything on this. This is just floating around in space. So we need a way to constrain this. Now, before we do, I want to look back at the assembly navigator. And you'll see that we still have the Vise assembly as our work part, and it is the parent file. And now we've added another part to this, another child to this parent file. Now, I forgot to change the reference set when we added that in, so I'll go ahead and change that now. So remember, I can right click on the slide bar, replace reference set with just the model. And so we've got the sketch that's went away, and also that datum coordinate system as well. So now I'm going to constrain this, and I'm going to do it in the way that would be done for this real part. And the way that we constrain these parts in an assembly is with our assembly constraints. So we can go to assembly constraints. Now in this window, you'll see these two areas that have different icons. The joint and the couplers come in handy for if we were doing some simulations, which we're not going to get into here. But we're actually not going to use those. We're just going to use the constraints themselves. These are sort of similar to like our make constraints, but instead of constraining like lines and points, we're constraining actual like objects. Now, I'm not going to go over all of these, but the more assemblies that you do, the easier it is to know which one that you need. So for our slide bar here, we want the center axis of this part to align to the center axis of the hole. So we could do, let's see, we could do a touch align and then infer center axis. And with that, what it wants us to do is select two axes. So notice as I approach the slide bar, we have the center line pop up. We can click on that, or we could just select the face of the slide bar here, the round face, and it would automatically essentially select the center line. Either way, so we can align that center line with the center line of our hole here. And you'll notice that it moved our slide bar so that now it is aligned with the center axis of the hole. So we could say apply. That's the other thing about doing assembly constraints. Sometimes you'll do like multiple. So like, maybe I've got actual 4 or 5 things to constrain. It's easy to just do like one after the other without hitting apply. But let's say you get to the last one and for some reason you accidentally close out or hit cancel or something, you actually lose all of that. So even though it kind of looks like it's saving your progress. It's actually not. So hit apply after each constraint that you do. It'll save your butt in the long run. Now, the other thing I want to do, so this is aligned, but I also want essentially the face here to be aligned with this face. So this is going to be press fit in to our Vise base here. So still in a touch align. It's a little confusing because it's the touch align constraint, but there's different orientations of this. So we just did the infer center axis, which aligned two axes together. Now we could do the align. What the align is going to do is I can select this face and the face of the Vise base here. And it's going to align those two faces together. And that's what we wanted to have happen. So now that bar has essentially been press fit into place. Now let me show you a different way that we could have done this. So we're back to, we just added our slide bar. This has not been constrained at all. So we could have gone to assembly constraints. And rather than doing infer center axis and then the align, I can just do a concentric. And I want this circle to be concentric with this circle. Now I did the outer circle of our hole and then the circle of our slide bar. What that does is it aligns essentially the axes and also the faces that were selected. Either way is fine. There's not a wrong answer here. I'm just showing you two different ways to do this. I'll say okay. And I do want to point out something here. So notice that this is a round feature, right? This is a cylinder and this is a hole. Like these should be round. But notice how it's faceted, right? It's just got like this line, 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 line. Sort of like how we would expect like an STL file to look, one with bad resolution, right? That's because when NX loads these parts in, it loads them not exact. So it loads them enough to where we can see what they are, but not fully loaded to save on like processing power. Whatever we go to like rendering, we're going to want to show exact on all. We want the parts to be as accurate as possible, but you can change that now. So if like you don't have to do this, but if this is bugging you, or if you want to see the exact features, we can actually. So if we go to the slide bar in our assembly navigator, if I right click on that, right under where we went to replace reference set, you'll see show exact. If I click on that, you'll see now we have a smoother line. It's not perfectly smooth because, again, there's still some throttling here on the actual component. But notice the difference between this circle and this circle. Very different. So for something like this, not really important. Before we go do the rendering, we do want to make sure that we do show exact on all of our parts. Let's do another part here. Let's do this this jaw. So two jaws, right? We have 6 and 5. We have a fixed jaw and a movable jaw. The fixed jaw lies on the back face. It's connected to the actual base of our vise, and the movable jaw connects to the moving jaw of the vise. Let's add the fixed jaw in. So back in NX, we'll go to add component. And the component that we want to add is the fixed jaw. Now, before I forget again, let's change our reference set so that we're only loading in the part itself. So if we come all the way down to settings, you should see component name, fixed jaw, reference set. Right now it's set to an entire part, and then our layer options as well. So on the entire part, I'm going to change it to where it's just the model. Now I'm going to move it so it's away from our vise base. So I'll come up here to specify orientation and just move it away from our vise base. And I'll just say okay. Now on the jaw here, we actually have a couple of holes. So these are threaded holes here. We have through holes on this side, so they're counterbored. That are a couple of socketed cap screws are actually going to hold on and fasten this thing together. So I'm going to use those to for constraints on our jaw here. So the stuff like this is important because you might think, well, I can just maybe align this surface to the back and then align this surface on the bottom to this bottom surface here, and that might be fine. But let's see if that would have worked. So I'm going to go to my assembly constraint, and I'm going to use another concentric here. And this jaw is backwards, so this is the hole that's going to align over here, right? So the jaw is going to actually be, this will be the face pointing inside. So with my concentric, I think I already have something selected. So for my concentric constraint, I'll select this back edge of that hole, and then this here. And okay, so you notice that it selected the right circles, right? And everything's aligned, but it's not aligned in the correct direction. So what I want is for this vice jaw to actually be facing towards me. So I'll click on reverse last constraint. What that does is it flips it. So there's two options here, right? So there's this option and then this option. Now this one was not correct. NX assumed, but it was not correct. But if I reverse the last option, that is what we are looking for. I'll say okay here because I'm going to actually just rotate this around just so I have a little bit better access to the other hole. So that's fine. Now this next hole needs to be aligned. I don't need to do a concentric though. I just need to align the axes because the face, the back face of the jaw is already aligned to this face of the vice base. So go to my assembly constraints. Now I'm just going to go to a touch align and an infer center axis. Now I'll select the two holes. They are aligned. And if we look at this, we actually have a little bit of clearance down here. So if we had just, touched this surface and then these two bottom faces here, then our holes would have actually not aligned. So I always try to assemble the device the way that I expect to assemble it in real life. Maybe I needed that clearance, right? Maybe we needed that clearance, but when this is assembled together with the holes, maybe we didn't have this clearance. So it's a good way to check things before you actually start making the parts, right? If we take a look at our assembly navigator, we now have 3 parts as in our parent file. Let's keep adding parts here. So let's add our moving jaw. So we're going to add 3. We're going to add the moving jaw in. So we'll go to add component. We want to add the moving jaw. I'm going to move it back so I can actually access it. And I'll say okay. The moving jaw, we have this hole that is going to allow for the jaw to ride along the slide bar here. So I want to add a constraint for that. But then also, let's add that constraint. So if I go to assembly constraints, I'm going to want to do it in first center axis because I don't want to do a concentric because I want the bar to still move, or I want the jaw to still move along the bar, right? Just not like left and right. I want it to move along the bar, but not away from the bar. So I'll do it in first center axis on that hole, and this bar, and I'll say okay. Now go and move the jaw, and notice so it's located correctly. I can move this along the bar here, but we do have a problem because it can still move into the Vise space, and that's not correct, right? That's not what we're looking for. I'm going to angle it slightly so we have access to this bottom right here, and we'll show you what we're going to do. So we'll go back to assembly constraints, and I want to do a parallel. So I can do a parallel between these two faces. So I can say I want this face and this face on the top face of our slide here to always be parallel. So I can say okay, and I can double check this. So let's see, will it still move along the slide? Yes. Will it rotate around? No, it will not. Will it move forward and back? It won't tilt. It'll just move along the bar. And that's good. That's what we wanted. Let's add the movable jaw here. So we're going to do the same thing or similar process to what we did with the fixed jaw. I'll move this back so we can actually see this side. So we'll go add component. I want the movable jaw. I'm going to move it away a little bit. And I'll say okay. Now there's no front or back on this one. It's going to be the same on both sides. It doesn't matter which face is touching the front of our movable jaw. So we'll constrain it the same way we did the other jaw. I'll do a concentric. And I'll select that circle and this circle. And it assumed correctly that time on the way that we wanted to constrain it. I'll say okay. And now it looks right? This looks like, yeah, that's exactly how it's supposed to look. But it's not fully constrained yet. So if I go and try to move this, right, I can actually rotate this around. This is what we're trying to avoid. We want to make it where this does not happen. So I'll go back to my assembly constraints. I'll do an infer center axis. And I'll align these two holes. Now, when the movable jaw moves, it's moving as one whole system. All right, so next component that we're going to add is the lead screw here. Now, but if you notice on the exploded view, the parts list, it has this labeled as lead screw subassembly. Now, why is this called a lead screw subassembly? It's because we've got the lead screw and the handle that's going to be added as one single component. Let's see what that looks like. So back in NX, we'll go to add component. Now we're looking for the lead screw subassembly. Now on the parts that are just right here, it's actually not on this list. So let's go to the folder that says open. And there is our lead screw subassembly. So I'll click on that and I'll say okay. And here is our lead screw and our handle. And now I'll do the same thing that we've done before, where I'll move this away. And I'll say okay. Now if we look at our assembly navigator, so here is our parent file, which has all of the components for our Vise assembly. But look, here's our lead screw subassembly. It is also a parent file, right? It's also a parent file. And if we break this down and look at the children files that are part of this, we have the lead screw and the handle, right? And you also notice that, well, we have to change some reference set information here, right? Let's go and change that There we go. It looks better. So we can actually add assemblies to other assemblies. We call those sub-assemblies. This is a great way to like break down components. And if we think about the way that it would actually be assembled together, it might be assembled in a way just like this, where this would be a sub-assembly component, which is then sent to the main line, making the actual Vise itself. Now this is nice because then this is a whole separate assembly. So we could do it a whole separate exploded view, a whole separate parts list, part numbers, all sorts of stuff just for this subassembly. So to constrain this, yes, we do have threads here, and we have in these internal threads. We're not going to try to align these so that this rotates like the threads will. We could sort of fake it a little bit, but really that's the kind of stuff that you would do for like the simulations. And again, that's not what we're doing here. We're just sort of assembling this together. So what I'll do is we'll go to assembly constraint, and I'm going to do a infer center axis on the center of the lead screw to where the threads are for the lead screw. And I want this pointing the other direction, so I'll actually flip this. And we'll say OK. Now I'm going to move this out. All right, I'm going to move this out just a little bit. So this is going to fit inside of our moving jaw. Notice we've got this recess here. What we're going to do, if I go to view and I do edit section here, what will happen is we have a set screw that's going to come down and essentially lock into place where this recess is, and it's going to allow the lead screw to still rotate, thus pushing or pulling the movable jaw here. But the set screw is going to make it to where it doesn't pull out of the movable jaw. So to be accurate here, I want to make sure that this slot or groove actually centers on the hole for the set screw. So maybe we designed this and the hole was too shallow, or maybe the shaft is too long, right? There's a way that we can make sure that neither of those things are the case. So it might be helpful to do the view section and actually see this divided like this. You don't have to. I'll keep it like this so we can actually maybe see it this way. So we're going to do an assembly constraint. And what we want is a center. So center allows us to align different objects together, or center to objects along other things. So we have the subtypes where we have 1 to 2, 2 to 1, and 2 to 2. Essentially what this is saying is we can align one object between two faces, so like 1 point between two faces, 2 faces to 1 point, or like 2 faces to 2 faces. So when it says the two, we're talking about 2 faces that we select, and it picks up the center between those 2 faces. So for us, we have 1 point or 1 line between 2 faces. So we'll do a 1 to 2, and I can say I want this center line of this hole, that center line, to be centered between the 2 faces of our jaw here, or of our lead screw. I'll say OK. And I'm going to go back to the view, and I'm going to do edit section. I can make sure, right, that everything is positioned correctly. We could probably give us some clearance here, but the set screw is going to not be, like, we'll have some wiggle room here. So I'm going to say this is okay. We could add a little bit more clearance here, but we'll say okay for this. So now, if I were to move the jaw here, notice that the lead screw is moving with it. I still can't rotate this around or tilt it, right? But we can move it. So the only thing left on this is the hardware. So the screws, right? So we have these socket head cap screws for the jaws, and then the set screw to hold the lead screw in. I think that it's important to add these things in for our final assembly to verify the screws that we have, everything fits together, make sure that all of these things are in. But you do not have to model these things. So these are just basic socket head cap screws, right? Design around what's available to you. So these are off-the-shelf products, right? You'd be surprised how many companies or manufacturers provide a CAD model of some of these products. A great resource to use is McMaster-Carr. So McMaster-Carr has just about anything you could possibly ever want. And what's really great is that it allows you to download a CAD file. So here is just a 1/4 socketed cap screw. And maybe this is the one that we were going to use. It's not the one that we are using, but maybe this is the one that we wanted to use. Notice that we can download a step file, a SolidWorks file. We can either do the drawings of this. What works best with NX, surprisingly, is the SolidWorks file. Let me show you how we're going to do this. So maybe this is the bolt that I want to use, or the screw that I want to actually import into the drawing that we have, or the model that we have. So I'm going to download this, let it download. Now, if I go back to NX, okay, I'm going to open up that file that we just downloaded. So I can go to File, Open. I'm going to find that file. Now, I'm in the downloads and I don't see the file anywhere. If you come down to the right window, bottom right window, notice it's only allowing us to see part files, but ours is a SolidWorks file, right? So this is not going to allow us to see it. We have to change this to all files, and then we can see the SolidWorks file that we have. So we'll select it and we'll say open. And when we do, what it does is it opens the file up, and it sees it as a part file now. Now we don't get any sort of history behind the model, so we can't come in here and easily change this. But that's fine. We don't want to modify this. We're just going to use it. So now we can we can save it as what we want, right? We can save it as, rename it if we want to, or save it to a different location. And we have a socketed cap screw as a part file that we can add into our assemblies. And that's exactly what we have here. So let's add in the set screw that actually locks this into place. So we'll go back to assemblies, we'll go to add component, and what we're looking for is the set screw. I don't see, so we'll go to open, and there's our set screw. I'll say okay. And it doesn't look like it's loaded anywhere. That's probably because it's like right here in the center. So I'll go to specify orientation. Oh, it's over here. And I'll just move it up so we can actually access it and see it. Now this set screw is going to be centered along this hole. So we'll do a infer center axis. I'll select the center of our set screw, and then the center of this hole. I'll say okay. And I'm going to go ahead and just move this down that's located inside our hole. And maybe we're not sure, we want to double check that. Yeah, that'll work. Notice that we do have some wiggle room here. Now this is not actually set in place, right? So with this can be moved. But this would be fully threaded, and so, that would be fine, right? That's fine. But we do want to make sure that it's actually constrained. So what we'll do is we'll go to back to assemblies, we'll go to assembly constraints, and we can add in a distance constraint. Now what the distance constraint allows us to do is select two objects and then define the distance between them. So for this, I can say the top of our set screw to the top of the movable jaw. Right now we have it set as 0.095. What if we just change that to 0.1? That looks reasonable. We can say okay. Now this is fully defined. This is constrained. So it's not going to go anywhere. And we've verified that the setup is going to work. So let's add we have 4 socket head cap screws that are the 1/4-20 socket head cap screws to hold the jaws in place. So if we go back to assemblies, add component, we'll find the 1/4-20 socket head cap screw. And we want 4 of these. So on the count, I'm going to change this to 4. I'm going to move these up. And I will constrain these. I can do a concentric. So assembly constraint, concentric. On the concentric, what I want to do is I'll make sure that I get this bottom surface here. So don't get the top of the round. We want to do the bottom face, right? You gotta think about like what's going to be making contact with the vise body. So that circle, and let's do the back ones here, to the inner circle of the counterbore hole. And this looks wrong. It is kind of wrong. It's just the wrong direction. So we'll say reverse last constraint, and that's just going to flip it around. Okay. And this I was talking about earlier, where it would be really easy. It looks like, okay, select your next object, right? But if we were to constrain all of these, and then on the last one we accidentally exit out, it would erase all of the work that we just did to constrain these bolts. So make sure that you hit apply after each constraint that you actually do. Now I'll go through and add the rest of these for these bolts. And there we go. Now, notice that we have all these assembly constraints that are very visible. We can actually add those to a layer, or we can just hide them in our show and hide. And now we can test to verify that this works the way that it should, which that looks right to me. Now with assembly files, it's really important that the assembly file and all of the children files are in the same folder. If you save the assembly file to a different location and tried to open it, it would tell you that it couldn't find any of these parts. Okay, it needs to be in the same folder. However, for this assignment, what I want you to turn in is just the Vise assembly file, because I already have all of these files. I made these files. So what I can do is, if you just turn this in, right, just turn in this file, I can put it in a folder with all of these files, and then it can locate it when it opens it up. Okay. So make sure that you save this. Make sure that you save this, and just turn in the Vise assembly file to the Dropbox on Canvas. I don't need a folder, and I don't need all of these files. I just need the assembly file. But generally speaking, you want to make sure that your assembly file and all of the files that make up the assembly are all in the same folder. Otherwise, you're going to have some problems.